In this video, we're going to look at another example of how mass percentage calculations are used. The scenario presented to us: how many grams of the elements magnesium, nitrogen and oxygen are in a 58.4 gram sample of the compound magnesium nitrate? To do this, we're going to start by calculating the percentage mass of each element in the magnesium nitrate compound, and then we're going to calculate the actual mass of each element in the 58.4 gram sample. We need to start by calculating the molar mass of magnesium nitrate. It's going to be 1 times the molar mass of magnesium. There is 1 magnesium atom in this formula unit, plus 2 times the molar mass for nitrogen. You can see that the nitrogen has a subscript of 1, but it's inside some brackets and there's a 2 outside that bracket, so there's a total of 2 nitrogen atoms in the formula unit. And then we're going to add 6 times the molar mass of oxygen. The subscript for oxygen is 3, but again it's inside the brackets, and the 2 subscript outside the brackets. 2 times the 3 is a total of 6 oxygen atoms in this formula unit. We get the information from the periodic table for the molar masses of each of these elements, and the molar mass will be 1 times the molar mass for magnesium, 24.30, plus 2 times 14.01, the molar mass for nitrogen, plus 6 times 16.00, which is the molar mass for oxygen expressed to 4 significant figures. And plug all those numbers into the calculator. 148.32 grams per mole is the molar mass for magnesium nitrate. So we can start calculating the mass percent of each element, and the mass percent for magnesium will be the magnesium contribution, 1 times the 24.30, divided by the total mass, which we can get from the molar mass. Put that into our calculator, we get 16.38 grams. The percent mass for nitrogen will be the nitrogen contribution, 2 times the 14.01, we get the 14.01 from the periodic table, over 148.32, which again is the molar mass of the whole compound. Put that into our calculator, we get 18.89%. Finally, the percentage mass for oxygen is the contribution from oxygen, the 6 times the 16, divided by the total molar mass there, 148.32, and we get 64.72%. So we've got our percent mass calculations for magnesium, nitrogen and oxygen. What we're going to do now is we're going to convert those percent values into decimal form and multiply them by the total mass. So the mass of magnesium will be 0.1638, and the 0.1638 is the 16.38% converted to a decimal. So the mass 0.1638 times 58.4 grams, and that's going to equal 9.57 grams. Similarly, for the mass of nitrogen, it's going to equal 0.1889 times the 58.4 gram of total sample, and that's going to equal 11.0 grams. Again, we got the 0.1889, that's the decimal form of the percentage, 18.89%. Lastly, for oxygen, we convert the 64.72% into decimal form. The mass of oxygen, 0.6472 times the total mass of the sample, 58.4 grams, we get 37.8 grams. Add those numbers up in our calculator, we get 58.37 grams, which rounds up to our 58.4 grams when we restrict that to 1 decimal place, as we are required to do. So, using mass percentage calculations to calculate the actual mass of elements in a sample of a compound.